This is IAT355 Visual Analytics, Lecture 3, in which we're talking about statistics. A brief outline is that first we'll give a very brief overview of what statistics is about, and then we'll talk about mean, median, and mode, or giving a sense of what the average of a set of data is. Next we'll talk about frequency tables and histograms, and then we'll talk about distribution and dispersion, and finally scatter plots. So first let's just talk about a brief overview of statistics and the mean or median or mode to describe what's going on in some data. So statistics is the science of collecting and analyzing numerical data in large quantities, especially for the purposes of inferring proportions in a whole from those of a representative sample. It's a little bit similar to visual analytics. For this course, we'll really focus on descriptive statistics, and we won't really delve into other aspects of the statistical work, which talk about sampling and inferring proportions in a whole from a sample of a collection of data, about a huge amount of data. So the basic statistical operations that you should be aware of is first, descriptive statistics, and those are used to describe the distribution of a single variable or the relationship between two variables, or perhaps more variables, but we're just going to talk about one variable or two in this lecture series. The other thing that statisticians do is they are interested in inferential statistics, and the purpose of inferential statistics is used to establish relationships among variables. So you've got a bunch of data which have a bunch of variables, and the real thing that the data is about is much bigger than the amount of data that you've actually collected. So usually what happens is the data you have is a sample of a much bigger collection of information. And there's usually the assumption that that big collection of data has some kind of distribution, which is called the normal distribution. That is to say, it looks in a way we'll show you later on in the lecture series. So the data may be a sample of the whole set of data, and the questions that statisticians are interested in pursuing are things like building techniques about how to infer things from that sample, how to correctly sample the information, how to make sure that the sample properly represents what's going on in the real life phenomena of interest, and how we can use that small sample to properly understand what's going on inside that real world data collection, or that real world phenomenon. But what we're going to do now is focus on the simplest end of this thing, and that is descriptive statistics. So the simplest descriptive is the minimum and the maximum and the range. So we have here in our slide a very simple little data set with these numbers ranging from 45, as is highlighted in red, to 100. And, they are integer numbers in this list. And range is simply the difference between the minimum and maximum values. And clearly we've already identified what the minimum and maximum values are here by highlighting them in red. So what I'm going to do now is I'm going to go over to our Excel spreadsheet, which has the same data. You can see it's the same, 73, 66, 69, blah, 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 all the way to 100. 100 just happens to be the last one in the list. And there's 45 there. So Excel contains functions that enables you to identify the minimum and maximum. And no surprise, the name of the function to discover the minimum of a set of data is min. And here is the formula that I've typed into this cell. I'll do it again just so you can see it happening. So the way Excel works, if you're not familiar, is you type equals to indicate that there's a formula coming. You state the formula name, function name, min in this case, and then within parentheses, you state the range of values that you want to compute. So min, what it does is finds the minimum value in a collection of numbers. In this example, we've just shown min the collection of numbers that's in a column. It could be any number of columns in this range here. I've just used column B, and that's where the numbers are. Maximum is the same, and that's the maximum of the same collection of data. Given that we know how to understand the minimum and the maximum and the range, let's now talk about what we casually call the average of a collection of data. You could see in the previous example that there were a number of numbers in the range from 45 to 100, and you'd kind of like to get an idea of the total collection, what is called the central tendency, or the average, as we say in quotes here. Another thing that we tend to be interested in a data collection is the spread of that information. And underlying this is the assumption that there's some real thing going on, and we would like to get a sense of a very simple description of that real thing, say a single number that is the central idea of what's happening in that collection. So for average, using the lay term, there are three well understood measures as to how that can be computed. The first is mean, next is median, and finally mode. And we'll talk about these now. So measures of centrality allow us to summarize a data set based on some central tendency. And some pictures that we'll talk about in the next lecture segment following this one, we'll show pictures of what that means. The general term average, which I'm putting in quotes, has a practical and statistical meaning, which is called the mean. And what is the mean? It's the sum of all values divided by the number of values in the data set. And it is one measure of the central location in the data set. And here we see that data collection from the previous slide, from slide number 5, 7366, and we've just simply added all those numbers together and divided by the number of numbers to get a value 68.6. If we go to our Excel spreadsheet, here's the same slide again, the same set of numbers, and what I've done is I've computed the mean, and that is in Excel, the name of the function is average, just basically so that we can use the common terminology. The argument to that function call is once again the range of values, and it is computed for us. It is computed for us the value 68.6. So what the average does for you is it gives a good sense of what the central value is. Now, what I'd like you to do is to think about when might you not want to use the mean. I'll give you a couple of seconds to think that through. Okay, one of the drawbacks of the mean is that it is vulnerable to certain types of problems. So here we have a visual representation of a couple of very small data collections. And in this one, and in this one, the mean computes to 4.8. And so this one we see values ranging from 0.5, roughly 1, 2.5, etc., up to roughly 9. And they seem to be kind of distributed with roughly equal spacing. And it's roughly symmetrical around the point of mean. There's roughly as many points to the left as to the right. There's 7 points on this line, and there are 4 to the right and 3 to the left. This one here also computes the same value. There are 2 values very close to 0 and a number of 5 more values which are just above the mean value. And the mean is the same in both of these things. And one of the things that we'll use throughout this lecture series through lecture 3 is examples of distributions of data, of locations of data that compute the same value even though the way in which the data is organized is somewhat different. So one of the drawbacks of mean is that it can be influenced strongly by values that lie at extremes of the range, either very large or very small. And in this instance, even though there's a tight grouping of data between 4 and roughly 7, these 2 values that are close to 0 have that mean kind of at the leftmost part of this 5-element cluster here. So a way to deal with that problem or concern is to compute a different value, and that is called the median. So what is the median? The median is the middle value in a sorted data set. Half the values are greater and half the values in the list are less than the median. And so what it does is, instead of actually taking the values and adding them up, the computational method is to sort these values and pick the middle one, or if there's an even number of values in the list as there are here, pick the middle two and take the average of those two, take the mean of those two. So here in our Excel spreadsheet, I now have median identified here, and the Excel call, as you can see here, is equals median, and I have the same values here, but they've been sorted, and I've identified in red 67 and 69 as being the two middle values. And you can see that by looking that, yes, these are in sorted order from smallest to largest, and item 10 and item 11 are the two middle ones because there's 20 items in the list. And 68 and 69, take the mean of that yields 68, and that's the median value. On the slides, we have another tiny data set, 1, 2, 4, 7, 8, 9, 9. 7 is the median value, and I've highlighted it once again in red. So the median may or may not be close to the mean. That is to say, part of the reason why we're interested in it is because the median sometimes gives different values than the mean. And part of the reason why this is interesting is we know by definition that the median is the middle value in the sequence of values in the data set. And if the mean and the median are significantly different from each other, different by a large enough factor considering the entire range of values in the data collection, the combination of median and mean can be used to define if there's some kind of skewness or one-sidedness to the distribution. And you can see in this little data set here, there's a certain amount of skewness in the data. We have these two values comparatively far off to the left and a small cluster of 4 in this case at the median point and off to the right. So the density of values here is much higher than the density of values, certainly around this range. And computing the median and computing the mean and finding out if they're close to each other or far apart from each other, just simply numerically, gives us an indication that there might be something interesting happening with the data collection. Finally, the last measure of centrality is something called the mode. And what that is the most frequently occurring value in the data collection. Now that seems a little bit funky. And part of the reason why you might use it is that it might be that instead of numeric values, as we're showing here, it's a nominal data set that you might run the mode on. But you can compute the mode on any data collection, and we'll just compute it on the data collection we've been showing here. And so once again, here it is, not in sorted order, the same 20 items in the list. And there's 2 occurrences of the number 74, so therefore the mode is 74. For numerical data, it's generally not all that meaningful unless a large percentage of the values are the same value. And so for numerical things, particularly if they're real numbers, we're just looking at integers here, the mode probably isn't too useful a thing to compute. But it is useful for nominal or categorical data. So for example, the most common social media tool used by students is Facebook. That is a suggestion of a computation that will be done by computing the mode, the most common something or other. There might be a whole bunch of social media tools, but there's a finite and comparatively small number of them compared to the infinite amount of numbers, say in the integers or in the real numbers. So in using mode for categorical frequency, typically what you would do is you'd have, say, a bar chart, which is measuring the number of items in a particular category or the number of items of nominal data. So here's the car name, how many times that appears, it's roughly 7, train is roughly 5, bus is roughly 12 or 13 here, and tram is, again, roughly 5. So the mode of this data set is bus, because the bus occurs 13 times, and that's the largest number of occurrences of any of these data values, car, train, bus, and tram. So when do we use what? Well, it's dependent largely on how data are distributed. Note that if mean equals the median, which in turn equals the mode, and we'll show how that might be the case this last part in a bit, then the data are said to be symmetrical. However, a rule of thumb is you use the mean if the data are normally distributed, we'll define that more later on, and the variance is within some small range. And we use median to reduce the effects of outliers. So here we're showing a data set, and this is done using a histogram, which we'll talk about later on in this lecture series. And the mean and the median are separated by, a modest amount. So, and you can see that what the bars are doing is counting up the number of items within these small ranges. And we have non-overlapping ranges here. You can see that this peak occurs further to the left of the median, which in turn occurs further left than the mean. And so what this is a data set that is skewed to the left, and mode is here, median is here, and mean is there. And that indicates that the mean itself is not really telling you exactly what you need to know about what's going on in this data set. So in summary, given the type of variable, you should select the centrality measure, the measure of central tendency, according to what kind of data that you've got. For nominal data, that is to say names or categories, the best measure of central tendency to use is the mode, because typically you would expect a limited vocabulary of names in your nominal data set. And to pick the favorite, the most common thing, you choose the mode, because that's exactly what the mode does. For ordinal data, you are in good shape if you choose the median. So that could be data that you can, remember that's data that you can put in order, but you can't do computations on. You can't divide some value by something and get something meaningful from ordinal data. If you have interval or ratio data, you can compute the mean, and of course you can compute the median, but if the data are skewed, that is to say, kind of one-sided or the other, the median is probably the best value to use. Whereas if the distribution of data is symmetric, you're going to do well by computing the mean. Alrighty, so that ends the lecture segment 3.1, which has been about statistics overview plus mean, median, and mode.